All right. How are you, students? I hope so. You all good in your homes. And today we are going to discuss Chapter 1 Composite Functions. Important questions. Important questions means that are the board exam questions which are given from 2013 to 2019 years. Okay, so today's class we are going to discuss important questions that are board exam questions 2013 to 2019. And here in this composite functions, I already said to you chapter 1 plus chapter 2 is 7 marks. In this chapter 1, 1 mark is 1, and then another 2 mark is 1. So totally how many marks? 3 marks you are going to get from chapter number 1. In chapter 2, you are going to get one 1 mark question plus one 3 mark question, totally 4 mark, and both together 7 marks you are going to get. So in this session today, we are going to discuss important questions. And here, before going to class, one special request for you all students, because I found that you are not watching the videos, and I am taking so much struggle. Even up to 12 p.m. I was preparing for you all these videos. Kindly remember, you study well in your home for the examination point of view, because you are 12th standard students, and next year you have to score good marks. So if you want to be David Sir students, at least per day 1 hour spend time for mathematics. So now let's move on to the topic. Before move on to the topic, let's close our eyes. Let's have the prayer. God, kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. Let's move on to the topics. All right, let's start some important questions. This is our 1 mark question. If f maps R to R, f of x is equal to sin x, and g maps R to R, g of x is equal to x square, then find g circle f of x. It's a 1 mark question. So how to solve this? It is very simple. You already know g circle f of x is equal to g of f of x. Before going to that, you have to check whether it is 1 to 1 or on 2. Here G is R to R and F also R to R, so that it is obviously 1 to 1 and on 2. Because of that reason, G circle F is possible. So now G circle F of x is equal to G of F of x. G of, what is your F of x here? F of x is nothing but sin x. Just substitute here. So I'll write here, since f of x is equal to sin x. So now g of sin x. So here g of x is equal to, what do you know, x square. Wherever x is there, in that place what is there? Sin x. Just substitute x plus sin x. So g of sin x is equal to sin x whole square. So you can write that sin x whole square, that is nothing but sin square x. So what is our g circle f of x now? Therefore g circle f of x is equal to sin square x. So this is one of the important problem which was given in 2019 board exam. So this is about your first problem. I hope so you all understood. Here very simple. Wherever f of x is there, substitute sin x, because f of x is sin x. And then now what I was done here, g of x. So g of x is x square. Wherever x plus sin x, you have to substitute, then you get the answer. It's very simple, just simple substitution. This is about your first question. And now let's move on to the second. Now this is your second problem. If f of x is equal to x minus 3 upon x plus 1, then find f of x. So this we need to find, and it is a 2 mark question, and it is very important for your examination point of view. So let's move on to the problem. First, this bracket one we have to complete, and then we need to go for next. So first one, what is that? F of x. So now what is your f of x? So here f of x is nothing but x minus 3 upon x plus 1. So now wherever x is there, substitute x minus 3 upon x plus 1. So that means, so here x minus 3. So now you can write x minus 3 upon x plus 1 minus 3. That is upon, next one, x plus 1. X means here x minus 3 upon x plus 1. Here this full is called as x. What is that? X minus 3 upon x plus 1. Okay. So that is, you need to think as a x. Then only it is possible to solve this problem. So now after that, what I want to do here, it is plus 1 is there, just plus 1. Take LCM. X minus 3 minus 3 into x, 3x, minus into plus minus, 3 ones are 3 upon x minus 3. So here x plus 1 I am not writing, because anyway here I will write upon x plus 1, and now here also x minus 3 plus 1 into x plus 1 means you will get as plus x plus 1 upon, what is LCM? X plus 1. X plus 1, x plus 1 get cancelled. Now you can complete this part as x minus 3x. So that is minus 2x, minus 3 minus 3 minus 6 upon x plus x, 2x, minus 3 plus 1, minus 2. So now in both common 2, what is possibility to get? Minus 2 let we common, then we'll check whether what we are going to get. So now in this place, we'll common as minus 2, and what you get? X plus 3, because 2 3s are 6. Now in this place again minus 2 common, minus x plus 1. So that you are going to get, and minus 2 get cancelled. You get as x plus 3 upon 1 minus x. X plus 3 upon 1 minus x. Just substitute this in this. So now what I write here again? f of x. So now what is this f of x? We find f of x as x plus 3 upon 1 minus x. Just substitute x plus 3 upon 1 minus x. So now again, wherever x is there, substitute that. So what I do here it is, so we know that since f of x is equal to x minus 3 upon x plus 1. So x plus here, x plus 3 upon 1 minus x. So x plus 3 upon 1 minus x. Here what is there? Minus 3. So that minus 3 upon, now again x means x plus 3 upon 1 minus x. And here plus 1 is there, right? That plus 1. Take now LCMs, what you are going to get. So x plus 3, now minus 3 into 1, minus 3, minus into minus, plus 3 into x, 3x, and here 1 minus x upon, because LCM is 1 minus x. Next also x plus 3 plus 1 into 1 minus x, you will get as 1 minus x upon 1 minus x. 1 minus x, 1 minus x get cancelled. What is going to get? Minus 3 plus 3 get cancelled. Minus x plus x get cancelled. So x plus 3x, 4x upon 3 plus 1, 4. 4 get cancelled. You will get answer as x. So at last, what is your answer? f of x is equal to x. So that is your answer. So that is about your second one solution, and if you have any doubt you can ask me in the comments, so that again I can explain what is there. Nothing is there in this, just in the x place x minus 3 upon x plus 1 you need to substitute. First complete this bracket one, then that value substitute and you will get your answer. So that is about your second question. Let's move on to the next. Now let's move on to the next. That is your, if f maps R2 or f of x is equal to x square minus 5x plus 7, then find f inverse of 1. It's very simple. What we need to do here, it is always whichever is there, that is f inverse of 1 is equal to x, you have to think. Then what you are going to get, so whenever like these questions are f inverse of 1, f inverse of 2, then f of x in some equation form or quadratic equation given, then you need to use f inverse of 1 is equal to x. Let, then what you write. So now 1 is equal to, here f inverse, go to that side, f of x. So 1 is equal to, what is f of x here? X square minus 5x plus 7. Now here plus 1, go to that side, minus 1. So now x square minus 5x plus 7 minus 1 is equal to 0. X square minus 5x, 7 minus 1 plus 6, that is equal to 0. Then do that splitting method. So then you'll get as x square minus 3x minus 2x plus 6 is equal to 0 for factorization purpose. So then x common, x minus 3 minus 2 common, x minus 3, that is equal to 0. Then x minus 3 common in both, and then what is left, x minus 2, that is equal to 0. Then at last x minus 3 is equal to 0, x minus 2 is equal to 0, x is equal to 3, x is equal to 2. Therefore f inverse of 1 is equal to 3 comma 2 or 2 comma 3, or you can write this only 2 comma 3. This f inverse of 1. This is about your third problem. So if you have any doubt you can ask me. So that is about your problem number 3. Now let's move on to the problem number 4. All right, let's move on to the next important question here. So this important question is this: if f maps R to R and g maps R to R defined as f of x is equal to x square plus 3 and g of x is equal to 1 minus 1 upon 1 minus x, then find g circle f of x and f circle g of x. Very simple one. So first given f maps R to R, g maps R to R. So whenever R2R is there, then automatically it is 1 to 1 and 1 to. Let me move on this. F of x is equal to x square plus 3. G of x is equal to 1 minus 1 upon 1 minus x. So now first I need to find g circle f of x. Very simple. G of f of x, right? What is f of x value? Substitute now. F of x is x square plus 3. So now, you know g of x means 1 minus 1, 1 upon 1 minus x. Wherever x is there, substitute x square plus 3. So now 1 minus 1 upon 1 minus x square plus 3. So now what I will do, just cross multiplication. 1 minus into plus minus x square, minus into plus minus 3, here minus 1 upon 1 minus x square minus 3. So now plus 1 minus 1 get cancelled. So what I can write now in this place? So minus x square minus 3. So then I'm going to solve this problem. Okay. So what I will do here, just observe carefully. Okay. Let's go into that. Minus common, x square plus 3 upon. So here minus x square minus 3 plus 1 means minus 2. So minus x square minus 2. So now minus common here also, then it becomes as plus. Minus minus cancel, x square plus 3 upon x square plus 2. This is about your first one, that is G circle f of x. Now we need to find out f circle g of x. So now we'll go for f circle g of x. So now here also same, now f of g of x we need to write, and f of what is your g of x? G of x is nothing but 1 minus 1 upon 1 minus x. So let's simplify first here, then it becomes as easy for us. So now 1 minus 1 upon 1 minus x. Let me simplify. Take LCM. Here nothing is there means 1. Take LCM. 1 into 1 minus x, 1 minus x minus 1 upon 1 into 1 minus x, 1 minus x. Minus 1 plus 1 get cancelled. Minus x upon 1 minus x. If I need to remove minus symbol, this just interchange these two. So then x upon x minus 1. So you got answer is x upon x minus 1. Just substitute now this and that g of x minus x minus 1. So write here x upon x minus 1. Now wherever f of x is there, that is x square plus 1. So in that x place you need to substitute this. So now f of x means x square plus 3. X place substitute x upon x minus 1. So now x upon x minus 1 whole square plus 3. So now this square give to both terms. X square upon x minus 1 whole square plus 3. So now this we can write it as x square plus 3 into x minus 1 whole square. X minus 1 whole square is nothing but we can write x square plus 1 minus 2x upon x minus 1 whole square. Just simplify it. X square 3 into x square 3x square plus 3 into 1 3 plus into minus minus 3 2s are 6x upon x minus 1 whole square. So x square plus 3x square 4x square minus 6x plus 3 upon x minus 1 whole square. This is about your f circle g of x. So this is about your fourth problem, which was 2 mark. Here g circle f of x finding is 1 mark. F circle g of x's finding is 1 mark. So this is such a simple problems. So this was very easy. If still you have any doubts, you can ask me on YouTube comment section, okay, so that I can reply you. So this is about your fourth. Let's move on to the fifth. And next, one more important question. If function f comma g maps R to R are defined as f of x x square, g of x 2x, and then find f circle g of x, g circle f of x, and f circle f of 3. So first, always solution place, whichever given those you have to write. Given f maps R to R, g maps R to R, and then f of x is equal to x square, g of x is equal to 2x. Now write that f circle g of x. So this we can write f of g of x, and f of what is g of x? G of x is nothing but 2x. And what is your f of x? F of x is nothing but x square. X place here 2x, so that 2x whole square. That is nothing but 4x square. So now g circle f of x. That is g of f of x. So g of what is f of x? X square. So g of x is nothing but 2x. Wherever x is there, x square substitute. So 2 into x square. So that is about g circle f. And let's move on to the f circle f of 3. So f of 3. So f of 3 is nothing but f of x is x square. F of 3 means 3 square. So f of 3 square. So that is f of 3 square is nothing but f of 9. So f of 9 is nothing but here wherever x is there keep 9, 9 square. So 9 square is nothing but 81. Therefore f circle g is equal to 4x square. G circle f is equal to 2x square. Then f circle f is of 3 is equal to 81. So this is about your problem number 5, and if you have any doubt you can ask me whenever in the YouTube comment section. Okay, so that is about your 5th problem. Let's move on to the 6th. All right, let's move on to the next. Think on function f maps R to R given by f of x is equal to x plus 3. Prove that f is invertible and then find its inverse of f. How to find? If any function need to be invertible, you already know that the function should be 1 to 1 and onto. That means it should be bijective, then only it is possible to be invertible. So first we need to prove this is 1 to 1 and onto. How it is possible? So previously already I was explained in the examples and the exercise also how to solve 1 to 1 invertible in exercise number 1.2 and before examples. Let's move on to the 1 to 1 first. So let x1 comma x2 belongs to the R. So then what we can write, f of x1 is equal to f of x2. What is f of x? 2x plus 3. So wherever x is there, substitute x1 and x2. So then 2x1 plus 3, here it is 2x2 plus 3. 3 get cancelled. 2x1 is equal to 2x2. 2 get cancelled. x1 is equal to x2. Therefore, f is 1 to 1. Therefore, f is 1 to 1. When x1 is equal to x2, if you have proved, that is 1 to 1. Then let's move on to the onto. So onto what I need to do? So let y belongs to the R, then y is equal to f of x. So y is equal to 2x plus 3. And now send here, find and the x value. Plus 3 comes to your minus 3 is equal to 2x. 2 is multiplying, comes to your division. So y minus 3 upon 2 is equal to x. And whichever the rational form, fraction form, this is belongs to the R. So now we can write here it is. So this y is belongs to the R. So then x also here belongs to the R. Just substitute this in that place, then you prove that f of x is equal to y. So how I can do? That is f of x is equal to, so y. This I need to prove. So how to prove it is, so f of x place, just substitute this part. So what I'll do here, y minus 3 upon 2, that is equal to, so what is f of x? 2x plus 3. 2 into x is here, y minus 3 upon 2 plus 3. So now 2 get cancelled, y minus 3 plus 3, minus 3 plus 3 get cancelled, y. Therefore, f of x is equal to y. Therefore, f is onto. If function is 1 to 1 and onto, so therefore function f is bijective. Therefore, f is invertible. So it is invertible. So if it is invertible, how to solve? So last time I already proved f of x is equal to y. This implies what we can write. So y is f inverse of y is equal to x we can write. So therefore here write f inverse of y is equal to x. Then f inverse of y is equal to, what is your x? X value found it as y minus 3 upon 2. So write that y minus 3 upon 2. So then here again what we need to write? Just replace y with x. So f inverse of x is equal to x minus 3 upon 2, where x is belongs to the R for every. So this is about your problem number 6. So once again, you can understand clearly whenever like this question they given f is invertible, find it inverse of f. So first find one-to-one function, then onto function. These both are proved, then only the function is bijective, then it is invertible. Then you have to find inverse. Otherwise, if function is not one-to-one, or maybe the not onto, then we can say it is not at all possible to invert. So not able to get the inverse of f. So this is about your problem number 6. Let's move on to the other problem. Right, let's move on to the next question. If function f comma g r maps r f comma g maps r to r is defined as f of x is equal to x square plus 1, g of x is equal to x minus 3, then find f circle g of x, g circle f of x, and g circle g of x. Again, it is very simple one. So first write f circle g of x, and here I'll write g circle f of x, and here I'll write g circle g of 3. It's like your previous, I think it is your fourth problem manner, and let's move on to solve how we can solve this out. So f of g of x, and this we can write it as g of f of x, this we can write it as g of 3. So now f of what is g of x? G of x is 2x minus 3, and here g of what is your f of x? Just x square plus 1. And now g of 3 means wherever x is there, 3 substitute. So 2 of 3 minus 3. So you have 2x minus 3, x is there, that place 3 is substituted, minus 3. So now here we can write f of 2x minus 3 means what is your f of x? X square plus 1 means 2x minus 3 whole square plus 1. Same method g of x. G of x is 2x plus minus 3. So 2 into x plus here x square plus 1 minus 3. That is equal to g of 2 3 is 6 minus 3. So that is again g of 3. So already you found g of 3 as how much you got? 3. So directly if you want again substitute 2 into 3 minus 3, 6 minus 3, that is nothing but 3. And now let's simplify this. A minus b whole square, a square means 2x whole square, plus b square means 3 square, minus 2 into a is 2x, b is 3, plus 1. So that is again 4x square plus 9 minus 2 to 4 for 3 is 12, 12x plus 1. That is 4x square minus 12x plus 10. So now let's simplify this also. So 2 into x square, 2x square, plus 2 into 1, 2, minus 3. So now 2x square minus 3 plus 2 minus 1. So now you got answer as f circle g of x is nothing but f 4x square minus 12x plus 10, and g circle f of x is nothing but 2x square minus 1, and g circle g of 3 is nothing but 3. So this is about your problem number 7. So I hope so you all understood this problem number 7. So if anyone having doubt, you can ask me or comment on YouTube so that I can help you out. So let's move on to the problem number 8. Alright, let's move on to the next. Let f maps n to y is a function defined by f of x is equal to 4x plus 3, where y is equal to small y belongs to n, such that y is equal to 4x plus 3 for every x belongs to n. Prove that f is invertible, find its inverse also. It is again simple only, don't check these all functions and those all. So here f of x is equal to 4x plus 3 they given, and both are natural numbers, belongs to the natural numbers. So what you need to do is just like your sixth problem manner only, find first one-to-one proof, onto proof, and if it is bijective and f is invertible, then just write the inverse function. So it is very easy. Refer your problem 6 and exercise number 1.2 video lecture and examples. So these you need to refer, then you are able to solve, and this eighth problem is homework for you all. Okay, so that is about your eighth one. Let's move on to your ninth problem. Next one is very important and which was given in 2013. Set of positive rational numbers is defined as a binary operation star such that a star b is equal to ab upon 4. Prove that star is commutative and associative. If there exists the inverse of star in q plus, then find it. It is very simple solution. So first for commutative, so I'm not writing given and data. You can write given data all. And just for commutative, what I need to do? You need to know that commutative means what is that? A star b is equal to b star a. I need to prove. So first let me a star b, what is given? A b upon 4. Now what about b star a? B a upon 4. So this give equation 1, this give equation number 2 from 1 and 2. See, AB or BA both are same, upon 4 both are same, so that from 1 and 2, A star B is equal to B star A, therefore star A is commutative. So here you can write commutativity. So then next one, associativity. Associativity. So let me check. First A star B star C. First A star B means what do you know? AB upon 4 star C. So now this full is A and this becomes as B. Then AB upon 4 means, so first A is what? AB upon 4 into what is B? C upon 4. So that is nothing but ABC upon 4 4s are 16, because numerator having denominator goes to the denominator. So 4 4s are 16. So this give equation number 1. Then again A star B star C. So now A star B star C is nothing but A star B means AB upon 4. Then B star C means BC upon 4. Now again this as A and this full as B. Then AB upon 4 means what you get. So A, B, C. So and upon 4 upon 4. So that means A, B, C upon 4 4s are 16. Equation number 2. So now from 1 and 2, what we can say? A star B star C is equal to A star B star C. Therefore, star is associative. Okay. Then first find the inverse element. If you want to find, first you need to find identity element. So what is, you have formula for identity element? A star E is equal to A. So this is identity element property. Identity property. So A star E means you can write it as A upon 4, that is equal to A. A get cancelled. E is equal to 4 into 1, 4. So now, what is your inverse property? So that is inverse possible means yes possible, because it is a commutative associative. Because of that reason, and what we get that is, so inverse means A star, let X is inverse of A. Then A star X is equal to E. This is inverse property which you learned in your properties. Okay. So now A star X is nothing but AX upon 4. That is nothing but your E is nothing but again 4. So now AX is equal to 4 4s are 16. x is equal to 16 upon a. So therefore inverse is equal to 16 upon a. So that is about your problem number 9. If you have any doubt, you can ask me or comment me in the YouTube so that I can help you all again. So that is about your problem number 9, and let's move on to the last problem of today. Right, let's move on to the problem. Let f maps r minus 3 to r minus 1 and f of x is equal to x minus 2 upon x minus 3, then prove that f is 1 to 1 and onto. Let me think this as a and this as b. So solution, f maps a to b, because I thought this as a, this as b. So then I need to prove here it is f of x is 1 to 1 and onto. Let's move on to the first 1 to 1. Let x1 comma x2 belongs to the capital A. Then f of x1 is equal to f of x2. Just substitute in your f of x. So what is f of x? X minus 2 upon x minus 3. So here wherever x is there, x1 substitute. x1 minus 2 upon x2, x1 minus 3 is equal to x2 minus 2 upon x2 minus 3. Just cross multiplication, x1 minus 2 into x2 minus 3, and now x2 minus 2 into x1 minus 3. Just multiply x1 into x2, x1 x2, x1 into minus 3 x1, minus 2 into x2 minus 2 x2, minus into minus plus 2 3s are 6. Same method here, x2 into x1, x1 x2, minus 3 into x2 minus 3 x2. Now minus 2 into x1 minus 2 x1, minus into minus plus 2 3s are 6. So plus 6 get cancelled, x1 x2 x1 x2 cancel, and what is left now? So nothing is possible to cancel, and x1 sign one side, x2 sign on the side. So now here minus 3x1 sign that side, minus 3x2 sign this side. So here minus 3x2 comes to here, plus 3x2. Here minus 2x2 is there. And here it is minus 3x1, go to that side, plus 3x1 minus 2x1. So now 3x1 minus 2x1 is nothing but x1 is equal to 3x2 minus 2x2 is nothing but x2. So therefore this f is 1 to 1. Then now we are going to prove that onto. So onto function means let y belongs to R. R means here we need to think it is as y belongs to the B, and then we have to solve these all problems. So R, it is which numbers? It is real numbers, so that we can think that let y belongs to the real number. Then it is possible to solve for you all, so that it will be good for you. So that is, I can say that it is belongs to the R. So then what we can do from this? So now y is equal to f of x, right? Y is equal to, what is f of x here? X minus 2 upon x minus 3. So now just cross multiplication, then solve it. So let me do that. X minus 3 into y is equal to x minus 2. Then multiply this, what you get? Y into x, xy minus 3 into y, 3y is equal to x minus 2. X sign one side, y sign another side. So what is possibility to get this x sign here? Xy minus x is equal to minus 3y, go to that side, plus 3y, 3y minus 2. Now x common in both, y minus 1 is equal to 3y minus 2. X is equal to 3y minus 2 upon y minus 1, and it is belongs to the R. So now from this you are understood it is x value found, and this x value substitute in the f of x. If you get y, then this answer is correct. So let me check now. F of x place it is 3y minus 2 upon y minus 1, that is equal to y. So now in this place, what is your f of x? F of x means x minus 2 upon x minus 3. So x minus 2 means 3y minus 2 upon y minus 1 minus 2. 3y minus 2 upon y minus 1 minus 3. Take LCMs, what you get? 3y minus 2 minus 2 into y minus 2y minus into minus plus 2 upon y minus 1, and here it is 3y minus 2 minus 3 into y minus 3y minus into minus plus 3 upon y minus 1. Y minus 1 get cancelled, and check still any minus 2 plus 2 get cancelled, plus 3y minus 3y get cancelled. So what you get now? 3y minus 2y is nothing but y upon 3 minus 2, 1, that is equal to y. So therefore f of x is equal to y. Therefore f is onto. So now 1 to 1 means x1 is equal to x2, we proved, so that 1 to 1. Then onto means f of x is equal to y, we need to prove. We proved it, that's what f is onto. So what I need to prove in this? They said that prove that f is 1 to 1 onto. We proved it. That is about your 10th problem, and it is given in 2012. So these are your all board previous year board exams, and I was covered from 2019 to 2012, whichever board exam place given questions, those all I was solved. This is your chapter number 1, composite functions problems, which they given in your previous board examinations. So that is about your board exam questions. And one homework I was given, kindly do it, and if you have any problem in that, comment on YouTube so that I can help you all. And if anyone is needful, kindly share to them. So this is about your today's class, and may God bless you.